Hello, everyone. Thank you for attending Ingenu's Dallas Machine Network Launch webinar. My name is Kirsten Garvin, and I'm the Senior Marketing Manager at Ingenu, and I will be serving as your moderator. Following our presentation today, we will conduct a brief question and answer period, so please submit your questions during the webinar through the Questions tab on your webinar interface. We've also made available 2 handouts, which can be accessed via the Handouts tab, and we will send out a link to this presentation at its conclusion. With me today is our presenter, Dr. Michael Vodomsky, Ingenu's VP of Strategy and Analytics. We also have Mr. Ed Hightower, who oversees IoT and end-to-end business development for Ingenu. Now, I would like to turn the webinar over to Dr. Vodomsky.
Thanks, Kirsten. So I'm very excited for everyone here. We are very glad to be here announcing the Machine Network live in Dallas, bringing IoT connectivity to Dallas. This is big news and really means a lot to us and definitely to the people there. And we'd like to explain to you why this is such big news and what it can do to help bring the IoT and make it a reality in Dallas. So a little bit about who we are. It's important to understand us as a company and to know our heritage and why we're in this business and what we've done in this business. So we are Ingenu, and we are headquartered in San Diego, California, a big wireless city. And we were founded in March 2008 by some Qualcomm engineers who saw the need to bring connectivity to machines and to devices. We currently have about 120 employees who are all over the world right now and who work very hard every day to make RPMA, that's our technology. And we have some fantastic leadership who really have a lot of experience in the wireless industry. One of them, an advisor to our board, is Andrew Viterbi, the inventor of the Viterbi algorithm, but probably more well known for being a co-founder of Qualcomm. We also have Ivan Seidenberg, who is the founding CEO of Verizon. He's on our board. And then the chairman of our board is Richard Lynch, who is or was the CTO of Verizon. And then our very own CEO, John Horn, who founded the M2M group at T-Mobile some years ago, was very successful and spun off a company called Rayco Wireless, which was acquired by Core. So he has got tons of experience in this space, and our board is really stacked with the wisdom and expertise and helped us guide us quite a bit over the years. We also have a lot of key customers that we're proud to have served for so many years, and some of which you may recognize there. So that's a bit about who we are. So what is the machine network? Well, really, in its most fundamental level, it is a wireless network, bringing wireless connectivity that's designed exclusively for machines. And that's important because the kinds of data that machines need, it's very different from the data needs of human and voice usage. So like your smartphone, you stream videos on it, you make phone calls, you do that kind of stuff, and it's high bandwidth, so a lot of data. But machines really don't need that much data. In fact, 86% of devices that are connected today use less than 3 megabytes a month. In fact, 76% use less than 1 megabyte a month. So the vast majority of machines connecting to wirelessly to the internet or to their headquarters or back to the back office don't need very much data. And so the kind of connectivity and the way it's designed really matters, and making it so that it's suited to the needs of machines is important. Also, the machine network provides battery life like something you've never seen before. So we're pretty accustomed to recharging our smartphones once a day, which for many may be okay. But if you're a device, if you're a machine connected to the machine network, and you send out, say, 100 bytes of data a day, which is definitely something that we've already experienced. We have in Texas there a partner, well aware, who has that very data model, right? 100 bytes a day, and that device will last 20 years on one battery. That's a drastic difference between what we're typically used to when we think about wireless connectivity. So the machine network offers that kind of connectivity, which really allows for a great ROI. We also provide longevity. So anybody that's familiar with the cellular industry understands that you've got 2G, you've got 3G, 4G, 5G is on the horizon. And if you think about it and you compare it to, say, a car, and if you imagine a car needing to change its engine and the way it works every 9 to 15 years or so because the fuel has changed, that would be ridiculous, and it would really just upturn our economy and make things very, very difficult. But that's essentially what's happening with the traditional cellular technology. Is every 9 years or so a new technology comes out, and so all the devices that are used to that old technology need to begin finding new connectivity and changing out their modems or changing out their modules, changing out their SIM cards to make it so it's compatible with the new technology. But the machine network has guaranteed we have backward compatibility and longevity. We don't sunset our technology like other technologies do, and that's really important to also get that ROI from investing in machines. So the machine network provides the kind of data connectivity that machines actually need and use. It provides very, very long battery life and provides the longevity that these devices need to have a great ROI over the long term. So our technology that actually allows these things is called RPMA, and that's an acronym for Random Phase Multiple Access, and the details of that can be found at our website, but we don't need to go into that today. But we just want to show you, and we're not going to explain all these things here, but we really want to emphasize that the machine network has been years in the making, and that it is really the culmination of innovation up and down through our technology stack. But that innovation has brought real benefits and features to end users so that you can make phenomenal applications and really serve the needs of consumers and of businesses and enterprises today. It all begins down at the chip level with the PHY. We have developed the technology so that we have very little overhead when we make connections. LTE and other cellular technologies, no matter how simple you make them, are still going to have more overhead than is necessary. But we're able to we made our technology to meet the data needs of machines today. We also have robust connectivity. We use free spectrum, which allows us to drastically have lower costs than the cellular competitors. But it also we've been live since 2008 and have really honed our technology to be extremely robust, and that goes down all the way to the chip that is in our technology. In addition, we've chosen technology that allows us to have greater capacity and coverage than any of our low power wide area competitors, and this is huge because it means that we're able to grow with the Internet of Things as it grows. We're also able to cover areas that other technologies simply can't cover. We're able to cover Dallas with our technology very easily, and we can provide a lot of service and cover areas that aren't affordable for most. So that goes all the way down to the physical layer, or the chip, what our technology actually runs off on the hardware side. But we also, on our firmware, have developed a lot of innovations and have put a lot of hard work into it. And that's really what gives us the battery life. And to dive in just a teeny bit, just to give you an idea, if you think about transmit power control, now this isn't the only thing that allows for extremely long battery life, but it is important and is quick to be understood. It's basically when you have an endpoint, and that endpoint's out there, and it needs to connect to a tower somewhere, right? One of our towers, our base station or access point. It has to transmit at some power level or volume. And we've designed our technology so that it only broadcasts at the quietest level it can and still get the message through. And that's important because if you broadcast very loudly, then you'll be using more power than really is necessary. And other technologies simply don't do that, and they can't do that. Like a Sigfox or LoRa or those kind of technologies will blast at the highest power they have and multiple times. But we acknowledge every single message, and we have that transmit power control to adjust power as necessary to really only speak just as loudly as necessary. And that's important because it has implications for scalability. So right now, the machine network is live, and we're just getting devices on there. But as Dallas becomes more and more high-tech, and as applications are installed across the network, if we need to add more capacity, we can very easily, because the endpoints that are already connected will only speak or broadcast as loudly as necessary. And so if a new access point is put in between, say, two other access points, then the endpoints that are covered by that new area will automatically, without us doing anything, turn down the volume or turn down the power which they broadcast and only broadcast as loud as necessary. LoRa and Sigfox and others, they can't do that, and that's a real problem when it comes to really scaling a network all the way up into a global level. If you really want billions and 20, 30 years down the road, trillions of devices connected, you must be able to scale in that way. And others can't support that, and we've done that from day one. And finally, we just have efficiency. Our technology makes it so that we only use as much power and as much data as necessary to get the message through and no more. So it's really something we've worked on for many years. Finally, a couple of great stories for showing just the network robustness. The first I'm going to tell you is a story from Aruba. We have a network in Aruba that we've been supporting for a number of years. And there was a construction site where, unrelated to us, Ingenu, they were doing some construction, and the retaining wall next to a pole that was holding one of our access points gave way. And so the pole lost power and then toppled, at a dangerous angle, and it was kind of a mini disaster there for whoever that poor construction worker was that made that happen. But our access point automatically went to battery backup power and broadcasted. Was doing business as usual for a number of hours, and then eventually the battery failed. And so what we have is automatically our endpoints will find the next best AP, right, based on channel conditions. And so all the endpoints reconnected to different APs, and a few of them actually connected to an access point that was 48 kilometers away. And this is a real production system. And obviously that's not typical. Typically our endpoints don't need to connect that far away, but it happened the conditions were great for those ones. And the system worked flawlessly, and handover was done, and everything was connecting and sending messages just as usual. So that's really important to demonstrate just the robustness of the network and to show how we've dealt with these issues over the years and baked it into our system, even on a network level. And another story to demonstrate how robust our system is and our network is back in 2011, there was a large blackout in Southern California. And we were helping a utility. We had connectivity to a bunch of fault circuit indicators. And what those are is basically if the power goes out on a line, these battery-powered fault circuit indicators say, hey, there's no power here, and they keep broadcasting that. But they're also, this same customer of ours also had a mesh network, and that mesh network went down and was down for 72 hours. For quite a long time. All the while, our network was up and running and demonstrating, and showing where the outages were. So another demonstration of just the robustness built into RPMA. So this is what you're getting in the machine network, and we're very proud of the technology and have really worked hard to make it so that it serves the needs of devices, serves the needs of customers, and has really brought business value to others. And we're excited to offer that connectivity to Dallas so that Dallas can, makers in Dallas and application providers in Dallas can take the next step and really make some fantastic things on that connectivity. So with that, I'm going to turn it over to Ed, who is going to talk a little bit more about the machine network in Dallas. So go ahead, Ed, and take it away.
All right, appreciate it, Mike. Yeah, we're excited here in the Dallas-Fort Worth area. The whole North Texas area is going to benefit from this low-cost, powerful network. We turned it up last week, and we had a workshop on Friday, and we had 50 developers, solution providers come and learn how to interface to our node, which is consisting of an RF module and an ASIC, and then ultimately how to connect to our network. And then over the weekend, we were one of the sponsors for the DFW Hackathon, and there were over 1,600 young folks there, not all young. So they worked 24 hours on projects, and on one of our projects, I'll tell you more about that in a moment, that one was quite an interesting use of our network. So it's going to be available here throughout the whole area. As you can see from this coverage map, We've got 17 cell sites, and we're able to cover everything in the Dallas-Fort Worth area, including McKinney and Frisco, Denton, Fort Worth to the edge of Weatherford, all of Waxahachie, Mesquite, and Rockwall. So it's incredible the ability for this signal to be manipulated and transmit this distance at 2.4 is pretty amazing. But we have 38 networks around the world that have been in operation since 2008 that have proven out the reliability and the security of the system. So we're excited that this network is going to cover this area and be a very blanket the area very well. And it'll cover all the outside area and inside one wall. And as Dr. Banowski was saying earlier, that as we have to increase or need to increase the capacity of the network, we'll just drop in more access points into the system. And when we do that, not only do we increase the scalability, but now we start increasing the ability to penetrate deeper into these buildings. Because we tightly control the power level of the devices that are in the network, we can ramp them up and down depending on what the needs are, and we have multiple protocols that we use to get into these deep areas. And so we'll be able to not only blanket the area, but also cover deeply into these different basements and vaults and parking garages and things like that. So very exciting times. We have a lot of opportunities to put in place solutions that were not practical before. When you start trying to do it on a cellular network, you're starting to get into having to deal with 30 frequencies around the world. You have to deal with very expensive equipment and a certification process for each of the carriers, and plus the overhead of the protocols that it takes to set up these transmissions to each device gets pretty expensive, pretty heavy. And so ours is a much simplified network, there's no cost. These are free frequencies, so we're not spending billions of dollars to access and have access to these frequencies. So a big advantage for us. The protocol is very simplistic and easy to implement, and like Mike was saying earlier, we get 10 plus years, in a lot of cases it's going to be 15, 20 years that we're going to get out of the batteries for the remote. So an awesome possibility for applications in the future. And in the past, we've been able to monitor and keep up with devices, objects in the field that were expensive, so it was worthwhile to spend the money on 2G type of cellular machine-to-machine and IoT applications. But now, with the tool set that we're giving you guys, with the capability that the developers will have, they can create solutions for many other applications that are inexpensive but important devices and assets that we want to monitor and control, because this is a fully two-way network that we have. So as we were saying, this is a public version. The private networks have been out there since 2008. We've got 38 of them around the world. We're converting some of them to this public network, and we're going to be in Dallas is first, and then we're going to do Phoenix, and then Austin, Houston, San Antonio, all the major cities in California, and Atlanta will all be done here before the first half of the year. Mike, can you advance the slide? There's no control on my screen. So the network and our capabilities are going to be available here, not only all through 30 cities by the end of this year, thanks, but also since we announced the 30 cities in November of last year, and then we went to Barcelona for the Mobile World Congress, we were approached by entities around the world, and we now have over 25 countries that will be putting the RPMA, the Ingenu machine network, into here shortly as well. And since this is the same frequency band, the 2.4 band, gigahertz, we'll be able to create equipment here. And what I'm excited about is the Dallas-Fort Worth area. We have the resources, the talent, the entrepreneurial spirit to create solutions. And as the network rolls out to the new cities and the other countries, we can take these solutions we create here and roll them out with our network. So we have a first-to-market capability, possibility here. So I'm hoping to get more and more developers and systems providers and solution providers on board so they can start creating solutions that can roll out with us as we roll out in the future. Now, as Mike was referring to earlier, WellAware has had one of those private networks, and they've been covering the Ford Shell Basin, which is from Laredo to south of San Antonio, over through College Station and then north of Houston. And they were so impressed with the network and how well it worked, but it had so much capacity when they heard that we were thinking of putting in the 30 cities around the world, around the United States. They talked to us about converting their private network to a public network. So they'll continue to use part of it for their usage, but let us convert over to a public version of the network. So we're going to be able to cover not only the major cities, but much of the area here in Texas as well with that network. So it's going to be an exciting time. So Mike, would you advance one more slide? And we have several other examples that the network can be. So with this tool set, if you start thinking about what if we could reach out and touch, control, monitor different devices out there. In the past, it was too expensive to do that. But now if we had a simple solution set and a very inexpensive one, but one that was very robust, it had good coverage, what could we do then? So at the hackathon, we had one of the teams that wound up winning our award. It's called Recycle Wars. And what they did was they took our network. The network was live there at Gillies, and they made a game out of recycling. So the idea was that you take your recycling material and you would scan it in and put it into a bin then that would weigh it. And you could have multiple sites then weighing the material that needed to be recycled, and then monitor and calculate, analyze how much data or how much they're collecting, and compare the different groups and pick, basically a winner then out of that kind of capability. So that was just one of the ideas that this thing could be used for. So as Mike was mentioning earlier, at Aruba, we put in a system there. We were talking to Aruba through one of our partners, or with one of our partners, LED Roadway, and the LED Roadway put in and replaced the existing lights on the island. And when you do that, you immediately save over 50%. It's like 59% savings if you put in LED lights just to begin with. But then with our control system, you can then monitor and modulate how those lights are used. So in the middle of the night when nobody is there, you can dim them down some. If you have situations come up where you need to turn off lights in a certain area and brighten the lights, or change the lights in another area, the color, or have them start flashing, so you're directing people down this particular route, you have flexibility now to be able to do that. And when you start able to control your lights and more like that, you can save another 21%, so you're saving up to 80% over the old lighting system that you had, and you have the ability now to communicate and do things with the lights that were never possible to do before. So if you move to the next slide, Mike. So another great idea. So if you have these assets and money bags, when banks have transfers, businesses want to transfer their money from one location or back to the bank and whatnot. You have these money bags. So if you could put a tracker in those, then you could keep up with where that money is going, what's happening with it, where it is at any time. And if it gets stolen, then you can track them. So this is one of the things that's being implemented in South Africa. So it's just a matter of time before we start implementing those kinds of valuable and low cost to implement solutions then that will help us improve the way that we deal with the world, the way that we can see things. With the Internet of Things, we now can start collecting data from many different sources because it's going to be economical and it's going to be pervasive. And then we're going to be able to pull that data back in and look at various data sets and different domains and make decisions that will help us improve our life and make our life easier and be a more complete picture of what's going on and how we need to deal with the world and make things better for us. So we hope that you guys will join us and become part of the solution here and help us expand. We're an enabling technology. We're a piece of the puzzle. We're the connectivity part. I think of the Internet of Things as three parts. You've got the devices in the field, you've got the connectivity, whatever that is, and then you've got the back end, which can be solutions and applications and storage and analytics back there. So it's a very complex system. That's not our play. What we do is the connectivity part. But by doing that, we enable the ability to monitor and control and analyze devices and situations that were never possible before. So come help be a part of that and use your minds and your ideas to help create these new solutions that we can then roll out with our network all the other places in the United States and the rest of the world as well. Now we have a development kit for $150. So if you're interested in getting that, contact us. There, Mitch Mills and myself are available to talk with you. We can set you up with a $2 demo, a $2 a month demo account then, so that you can access the network and try out your different things. This development board is called a RACM, R-C-A-M, and it's much like an Arduino or a Raspberry Pi, but it's for to talk to our network. So you'll be able to quickly be able to master it and get your applications then figured out. So I believe that's the end. What we want you to do is think about how could you use this network and create solutions that would be helpful to our community and to the rest of the world. I guess now we'll open it up to questions and answers. Did you want to open it up the line there, and Kirsten, and we'll take questions?
Yes, thanks, Ed. So I just want to remind everyone, if you'd like to submit a question, please do so through the questions tab on the webinar interface. So we have a couple questions that have come in. First one is developer documentation available online? Mike? Ed?
Yeah, it is, and we can make it available to you if you're not seeing it right off. And let me know if you have a particular need of something more than what's out there, and I'll be sure to get it for you.
Great, thank you. Next question is, can you give me some examples of what types of devices I can make with your development kit? Mike, would you like to take that? Or Ed? Okay, sorry, Ed.
No, that's fine. The beauty of it is, with electronics, we're on this exponential curve, so everything is doubling in its horsepower every 2 years, and the size is going smaller and the cost is. So we're on that same curve right now. So we have our node, which is an RF board and an ASIC as well, and we're shrinking that down. So by getting the size smaller and smaller, then it's going to be able to fit into more and more objects right now. So it's like about 1 inch square, the size of it presently, and it'll get down even smaller than that in the near future. So when you've got that, and it's battery powered with a button battery, you can put that into objects that could feasibly, be very, very small. So as we talked about earlier, you've got the money bags. At some point, we're going to be able to put them into dog tags. We put them into tags, name badges that you would have, so that you're going to be able to walk around and be able then to interact with the people that are traveling and moving and in your business operations, and even for valets and things like that are possible in the future. So right now, any object that is without power, but you need to monitor it and maybe even control something at that remote site, those are the sweet spot. As long as you're not collecting a lot of data, so 80% of all the applications require less than 3 megabytes a month, that's our sweet spot. So our network will handle that. It will talk to that device. we're relatively low latency, but there is latency involved in the machine-to-machine network. So you can't be real time, but if you can handle a little bit of delay, which most applications can in this world, then the Ingenu network is perfect for that kind of situation.
Great. Okay, I think Mike, I'll direct this question to you. What about robustness or resilience from types of attacks, security in nature, that could occur in the unlicensed spectrum?
So the security of the machine network is basically equivalent to that of it's cellular grade security, and so anything that is vulnerable or the kinds of things that happen over cellular connectivity, we have cellular grade security on our network, so the same kinds of vulnerabilities exist. So there's really no change in the risk profile of using the machine network versus using a cellular network. So are there zero-day attacks that could come? Sure, but that can happen on anything. But you're getting the same security profile with the machine network as you are on a cellular network. So really, it doesn't get much better than that, frankly. And if you want to learn more specifically about the kinds of security that we have implemented in the machine network, you can download a white paper. All the recommendations we make for security, we definitely implement ourselves. So good question. Security is very important to us and very important in the Internet of Things, and it's something that we've taken seriously from day one. Most of our private networks in the beginning were utility-based, and so highly regulated, had a lot of standards and protected critical assets, and we were able to support federal standards and other standards that those utilities needed to be supported. So the real takeaway here is highly secure and has been used in very demanding industries for many years. So take comfort in that. Thank you.
Okay, I think Mike, this is probably another one for you. How well does the radio work for indoors?
Good question. So it depends on the deployment. We were able to support the hackathon no problem there in Dallas. So in Dallas it's fine. We didn't need to bring any special access points or anything. Everybody developed inside, was working without any issues. So obviously the way you deploy a network changes the coverage and things. If you've experienced cellular coverage, sometimes in building isn't as good as it is outside. But right now, our typical deployment is one wall, which is pretty common for cellular as well. But the proof's in the pudding. We had the hackathon, had no issues. It was great. Everyone was connected and doing just fine. So yeah, it's basically what you should expect and could expect from a wireless provider.
Okay. Another question is, do we have an API that supports the machine network, and what does it look like?
All right, I'll take that, Ed. So our how do you interface with the network is I think the underlying question. I mean, how do you actually interact with your devices? So we have well, there are a couple things. We do have a platform for making sure and checking on your devices. It's called Intellect. That's for managing your devices and seeing what kind of data usage they have and billing and that sort of thing. But there's also just the interacting with the device itself and trying to figure out what it's doing and we're actually using it to do whatever it's supposed to do. And we have a REST API that you can use. There are also other protocols or other APIs, that you are able to access. But we support REST interfaces. So if you have an Amazon or AWS-based platform that you want to use, you can make calls from there to your device using REST, RESTful calls, or some whatever other platform you want to use. But yeah, so REST interface, very common, very useful. That's standard across the industry, and we absolutely support that as well as some others as well. So good question.
Okay, and we have a question about where people can find where the machine network is going to be deployed, maybe outside of the Dallas area, where it's coming next. And I guess, Ed, do you want to answer that question?
Sure. Now, if you go on the website, the ingenu.com website, there is a page there where you can go in and look and see where the network is going to be, and you can plug in your zip code and confirm that it will be in that particular area. We've got a list of the 30 cities, and the Phoenix, Dallas, and Riverside and San Diego and Miami are the first quarter of this year, and we're going to be putting in then the Austin, Houston, San Antonio, and then much of Florida as well, and Atlanta then by the first half of the year, and then the rest of our cities, which is like LA and Philadelphia and Salt Lake and Denver and Chicago, those will be installed the second half of the year. We should have all 30 up and working by the end of the year, and we'll be working on the 25 plus countries as well simultaneously.
Okay, great. Okay, so that's about it for the questions. We do have several people that have asked how they can purchase the development kits or how they can learn more. So again, we will be sending out this presentation. It has the contact information in there, or you can just go to our website, and we do have a form that you can fill out that if you like additional information. And we thank everybody for being on the webinar today, and hopefully we'll have you on subsequent webinars. Thank you.